Earth's atmosphere is a remarkable and dynamic system that surrounds our planet, playing a crucial role in regulating climate, weather, and even the air we breathe. One of its lesser-known but essential functions is its ability to mitigate pollution. While pollution levels have increased dramatically due to human activities, the atmosphere has evolved a variety of intricate mechanisms that allow it to beat or eliminate many harmful pollutants. But how exactly does the atmosphere carry out this task? This question leads us to explore the scientific processes involved in pollution removal and how the atmosphere helps to cleanse itself. To understand how the atmosphere deals with pollution, we must first look at its structure. The atmosphere consists of several layers, each with its own distinct characteristics. The troposphere, the lowest layer, is where most weather events occur, and it's also where most pollution accumulates. Above this lies the stratosphere, home to the ozone layer, which absorbs and scatters ultraviolet solar radiation. The mesosphere and thermosphere are higher layers that play lesser roles in pollution control, but are involved in atmospheric dynamics. Each of these layers contributes in unique ways to how pollution is processed and removed. Pollution can take many forms, from visible smog to invisible gases and particles. Some of the primary types of pollution in the atmosphere include greenhouse gases like carbon dioxide, methane, and nitrous oxide, which trap heat and contribute to global warming. Particulate matter, which consists of tiny solid or liquid particles like soot and dust, can cause respiratory problems and contribute to smog. Ground-level ozone, formed when nitrogen oxides and volatile organic compounds react with sunlight, is another common pollutant, particularly in urban areas. Sulfur dioxide and nitrogen oxides, emitted by vehicles, power plants, and industrial processes, can lead to acid rain. Volatile organic compounds, emitted by vehicles and factories, also play a role in creating ozone. The atmosphere has developed several natural mechanisms to combat and remove pollution. One of the most important of these processes involves chemical reactions that break down harmful substances. For instance, hydroxyl radicals, which are highly reactive molecules, play a significant role in cleaning the air. These radicals react with pollutants like methane and carbon monoxide, converting them into less harmful substances like carbon dioxide and water. In the stratosphere, ozone itself helps to break down certain pollutants, such as chlorine compounds, that could otherwise deplete the ozone layer. These chemical processes help reduce the concentration of harmful substances in the atmosphere. Water vapor is another key player in pollution removal. As water vapor rises into the atmosphere, it forms clouds that can trap pollutants like sulfur dioxide, nitrogen oxides. When it rains, snow, or fog forms, these pollutants are removed from the atmosphere in a process known as wet deposition. This natural filtration system helps clear the air and return pollutants to the Earth's surface, where they can be processed or neutralized. Without this process, pollution would remain suspended in the atmosphere for much longer, leading to more severe environmental effects. The ozone layer, located in the stratosphere, is also instrumental in reducing certain pollutants. It not only protects life on Earth from harmful ultraviolet radiation, but also absorbs and neutralizes chlorine compounds, which could otherwise destroy the ozone layer itself. The ozone layer acts as a natural filter, preventing these dangerous chemicals from accumulating in the upper atmosphere. In addition to these atmospheric processes, Earth's vegetation plays an essential role in pollution removal. Trees and plants absorb carbon dioxide during photosynthesis, a process that not only reduces the levels of this greenhouse gas, but also produces oxygen, helping to maintain a healthy balance in the atmosphere. Forests, grasslands, and wetlands all contribute to cleaning the air by capturing pollutants and storing them in the form of biomass. However, human activities have significantly impacted the atmosphere's ability to manage pollution. Industrialization, urbanization, and the burning of fossil fuels have introduced massive amounts of greenhouse gases, particulate matter, and toxic substances into the air. These activities have overwhelmed the natural pollution control mechanisms, leading to higher concentrations of harmful pollutants in the atmosphere. The burning of fossil fuels, for example, has resulted in a substantial increase in carbon dioxide emissions, contributing to global warming and climate change. Human-driven pollution has also led to the formation of smog and acid rain, both of which place additional stress on the atmosphere. Ground-level ozone, a major component of smog, is a direct result of pollution from vehicles, industrial emissions, and power plants. This smog not only affects air quality, but also impairs the atmosphere's natural ability to clean itself, as pollutants remain trapped near the surface instead of being broken down or removed. The excessive release of sulfur dioxide and nitrogen oxides into the atmosphere has also increased the occurrence of acid rain. This rain damages ecosystems, bodies of water, and infrastructure, and it further challenges the atmosphere's ability to process and remove pollutants effectively. As more pollutants are released into the air, the atmosphere's natural cleansing systems become overwhelmed, and it becomes increasingly difficult for the planet to recover from the damage. To address this growing challenge, humans have developed technologies that assist the atmosphere in its pollution removal efforts. Carbon capture and storage (CCS) technologies, for example, capture carbon dioxide emissions from power plants and other industrial sources before they enter the atmosphere. The captured CO is then stored underground, preventing it from contributing to global warming. Air purification systems, such as scrubbers installed in industrial plants, help remove sulfur dioxide and nitrogen oxides from the air, reducing their contribution to acid rain and smog. Urban planning has also evolved to address pollution through the creation of green spaces, rooftop gardens, and reforestation projects. These initiatives not only help absorb carbon dioxide, but also reduce the urban heat island effect, which can exacerbate air pollution. By incorporating more green areas into cities, we can return to nature's methods of cleaning the atmosphere, while also benefiting from technological innovations that complement these natural processes. The transition to renewable energy sources like wind, solar, and hydroelectric power is another important step in reducing pollution. By moving away from fossil fuels, we reduce the emissions of greenhouse gases and particulate matter, thereby easing the burden on the atmosphere's natural systems. These renewable sources of energy provide cleaner alternatives that support the atmosphere in maintaining a balance and reducing the impact of human activity on the environment. The future of pollution removal will require a combination of natural processes, technological advancements, and global cooperation. As pollution levels continue to rise, the atmosphere's self-regulating systems may struggle to keep up. Stronger regulations and global efforts to reduce emissions will play a crucial role in alleviating this burden. The Paris Agreement, which aims to limit global warming to well below 2 degrees Celsius, represents a significant step in reducing the strain on the atmosphere's ability to manage pollution. In addition to regulations, scientists and engineers are developing new technologies to capture and neutralize pollutants more efficiently. Artificial trees, for example, have been designed to absorb carbon dioxide more effectively than natural trees, and air purifiers are being developed to target fine particulate matter that is difficult to remove through natural processes. These innovations offer hope for a future in which the atmosphere can better manage pollution and ensure the health of the planet. Ultimately, the key to a cleaner future lies in the collaboration between natural systems and human-driven innovation. While the atmosphere can absorb and neutralize many pollutants, it cannot do so indefinitely if pollution levels continue to rise. By taking action to reduce emissions, invest in clean technologies, and protect the natural processes that support the atmosphere's health, we can ensure that the Earth remains a safe and habitable place for generations to come. The atmosphere may not be able to eat all the pollution we produce, but with collective effort, we can ensure that it has the tools it needs to protect us from the consequences of our actions. Unveiling the unseen processes that shape our world, we discover how nature and technology are coming together to protect our future. For more insights into the hidden wonders of our planet and how we can help preserve it, make sure to subscribe and stay tuned. Together, we can learn how to balance progress with sustainability, ensuring a healthier planet for generations to come.